Okay, so this will be recorded, as we heard. Welcome, everybody. This is a special SEMA Lab lab meeting. I think this is the biggest lab meeting we've ever had. So we were going to do this in a hotel room, and we realized Shamil's talking. I think we're going to attract an audience. So this is a special secret talk, invite only, and you're all a part of that. So thank you for joining. So SEMA Lab is a lab at the Center for Consciousness Studies where we study mindfulness, meditation, and ultrasound. It's a lab that Shenzhen, John Allen, and I founded a couple years ago, and we decided to have it here at the conference since this is going on during lab meeting. We're very happy to have Shamil Chandaria speaking to us today. We had thought about not recording this so we can just go as deep as we want. So I don't think that this will be shared. So feel as safe as you want to talk about the topics that we're going to dive in today. And if we decide to share it, I think we'll let folks know, or we'll snip out anything that's weird. So thank you to Shamil for coming today. I think, so what you'll do is give a talk first, and then we'll dive in. I think we have the room from 1 to 3, so we have a lot of time to dive in. And do you want to take questions during the talk, or?
Yeah, maybe let's reserve them for the end.
Okay,
that's it.
So you'll get through your slides first. Well, we're in for a treat. So thank you very much for coming to SEMA Lab and gracing us with the talk.
Brilliant. All
Yeah,
right. No, thank you. So yeah, I gave a version of this talk at a neuroscience conference at the end of last year, which Shenzhen and Jay were at. So there'll be some repetitive material there, but this talk goes much further than I've ever gone in public. So yeah, so well, a little bit about the title and my background. Well, my main position is at Oxford. I'm also at the Center for Psychedelic Research at Imperial. And this talk is going to be quite detailed. Shenzhen insisted that I keep all the math in. So it's going to be a lot about the brain and a lot about the mathematics. And so, but there will also be a lot of phenomenological content. And I really will be talking about awakening and different levels of awakening. And the title, Computational Neurophenomenological Account. Well, that's a big mouthful. So let's just try to understand what that is. Okay. Okay. So there are a couple of ways to look at the world. We can look at the world using our first-person phenomenology, our conscious experience, a first-person point of view, and we can look at the world in a third-person perspective. What's going on in the brain. And there is a problem. It's been around for a long time, but it's generally known as this explanatory gap. And it's very much related to the hard problem of consciousness. And it's a real problem. This is what this conference is about, to some extent. And there is something kind of marvelous that's happened in the last 10 to 20 years, which is we have started to get a bridge between these two perspectives. And that bridge is a third thing, which is a computational model. And specifically today, I'm going to be mostly talking about things like predictive processing, the free energy principle, the Bayesian brain, which is arguably the leading theory of the leading contender to what a general theory of the brain will look like. It really is, an incredible universal framework. And actually the architect, one of the main architects of this, Carl Friston, is currently pretty much the most cited neuroscientist at present. Now, this computational model gives us a bridge from the computational model to what neural mechanisms. We have an idea of it gives us a model of what's going on at an algorithmic level in the brain, and gives us this algorithmic description, and actually can generate experimental predictions. But we also have this other bridge, which is the computational model turns out to be a model of phenomenological properties. I mean, this is really important. This is absolutely critical. Our experience has information. This is black, not white. That's like one bit of information. And this is what the model is talking about, is an information theoretic object. And there will be homologies to our first-person perspective. We will see what is represented in the model, what represents conscious experience. We will find homologies about what is attention, the attention mechanism within this model. So there'll be this fantastic bridge here. And still no. So this general way of looking at things is called computational neurophenomenology. And what we're actually going to be doing is an odd methodology, which comes from philosophy, the method of reflective equilibrium. So we're going to go use phenomenology to influence the computational model. We're going to use neural goings-on to influence the computational model. We're going to go we're going to go all the ways and find something that coheres. So that's the method of reflective equilibrium. Okay, so we're standing in front of a tree, all right? We're observing the tree, and something amazing happens. There is an impression of this tree somehow miraculously that I'm experiencing. How does that happen? What's going on? Am I actually seeing the tree? I mean, this is a deep issue in philosophy, which we'll come back to. There was a very important distinction made by Immanuel Kant. Immanuel Kant is like the Isaac Newton of philosophy. And he made this distinction saying, look, what the world we experience is our phenomenal world, the way things actually appear to us. But we actually don't know how things are in themselves, what he called the noumenal world, Ding an sich. And what he argued is that actually we use concepts like space and time and causality to organize our sensory experience. So we're bringing space, time, and causality and other things, what is now called Kantian hyperpriors, to structure our phenomenal world. And this was a huge revolution. He called it the Copernican revolution, and which basically says that objects must conform to our cognitions rather than cognitions conform to objects. And that was, that's really goes against common sense. And this amazing polymath called Hermann von Helmholtz then takes Kant's ideas forward and first suggests that perception is an inference. So let's look at this perception. So Descartes, thought that, well, it's kind of obvious, like we got windows in the front of our heads that are somehow looking out at the world as it really is. And, that's how perception works. But that can't be how it works. And, everyone can know this. If you take your hand and put it at arm's length. Let's all do this. This is experiential. And look at your thumbnail. That's about all you can see in color and accurately. That's to do with the fovea, the macula. That's all you can see. And yet, look around you. You see this beautiful world around you in color, by the way, which is not there. It's painted on by our minds. And it's all, straight lines and this cartoonish definition. And what's going on here? How are we seeing this? If all we can see accurately, we're certainly not seeing what's coming through our eyes. Here's a little interesting, if it works. Yeah. Okay. So you see this thing here. What's going on here? I mean, like, this is a little hint. This is of what your eye is actually seeing. Actually, it's a concession. It's way better than what your eye actually sees because, mostly it's black and white. What is going on there? Well, this is what's going on. You're actually seeing like a bee on a flower, but it's difficult to make sense of that. Yet we do that all the time. Somehow we can't make sense of what's coming through our eyes, but our brains can. So it's a very, what's going on? How does the brain do this? Okay, well, there is a theoretically optimal answer of how the brain does this. This is the mathematically optimal way, and the way it works is this. We get data from the environment. Let's call them the causes of sensory data. And I want to put causes in, causes of sensory data will be fine. But we actually don't know what's really out there. All we have access to is our sensory data itself, okay? But we're imputing some causes that we're trying to find. And the job for perception is to figure out the probability of what I'm seeing, the probability of the cause of the data given my sensory data. So I have access to some sensory data, and I've got to try to figure out whether, what's the probability that this is a tree given my sensory data. That's the job, that's the inference problem. And there is a unique method to do this. It's called Bayesian inference. And it's worth, for those of you who don't know this, I'm just out of interest. I mean, who remembers kind of Bayesian inference from school? And there's okay, so maybe 2/3, but it's worth covering this just a little bit, which is that the way you calculate this posterior distribution, in other words, what's the probability of this feature, for example, a tree, given my sensory data, the way you do that is by inverting the problem. You say, what's the probability of actually getting this sensory data, if it indeed was a tree, if it actually was a tree, times the prior probability of seeing trees in general, divided by this normalizing term, which makes probabilities add up to 1. Now, the problem is that this normalizing term is computationally explosive. Oops. To calculate this term, you'd have to go through every single hypothesis. You'd have to say, what's the probability that this data came from an alien spacecraft times the prior probability of an alien spacecraft, plus what's the probability it came from a snake times the prior probability it came from the snake. No, and we can't do that. That's just simply not going to happen. And so both in machine learning, in artificial intelligence, and in evolution, we cannot use this strategy. It's called computationally explosive. The Bayesian inference problem is computationally explosive. So what do? Well, let's take an inspiration from AI, neural networks, and machine learning. Machine learning, well, neural networks seem to do this. We feed in data, lots and lots of data into a deep neural network, and the network slowly extracts features. Initially, it extracts low-level features like edges and corners, a little bit what you'd find on the V1 area in the visual cortex. And then you extract mid-level features like noses and eyes and ears. And then finally, you get high-level features like faces. Right. Okay, so how does this work? Well, it works by doing something called supervised learning. So what we do is we feed in data into a kind of a random network. Imagine you're a baby, just kind of randomized network. And, it's maybe learned a little bit, but it doesn't kind of get it right. And you feed in, say, a picture of a dog, and it processes it up. I mean, neurons, the signal goes in and then is transformed at every neural level. And eventually you get some output called a feature vector. And we do this by training it with, let's say you put in a picture of a dog and it comes out that it's a cat. Well, that's not right, but you have the true features, you have some ground truth. And you say, no, it was actually a dog, okay? And that sets up a prediction error between the feature vector that you have, like it was a cat, compared to the feature vector, the truth, the ground truth. And there's this very important algorithm called the backpropagation algorithm that was figured out, and this is why we have the deep learning revolution in the first place, that then says, well, depending on this error, it's actually the squared error we use, you can actually adjust the synaptic weights, adjust the weights between these neurons, and then the network gets a little bit better at learning. And finally, it will classify correctly. Okay, so that's how neural networks work, okay? But why can't we use that? That's a brilliant way. I mean, evolution must have thought of that. What's the problem with using this? There's a big problem. There is no supervisor in the brain. We have no access to ground truth. And this is a very, very profound thing, okay? We cannot use supervised learning. There is only one thing that we have access to, and that is the data. We only have access to the data. What a predicament, okay? So what are we going to do? Well, an amazingly clever idea is to say, okay, well, if I only have the data, somehow I can predict the data. So what you do is you have the sensory data, it goes up a neural network into a feature vector, and this is called the recognition model. And sort of, you may get it right or not. It's sort of like and it might predict like some feature, like it's a dog or something. And then you say, well, if that is indeed what's actually going on out there, what would I then see? What would I see? What do I predict my pixels would be? And you then go up the stack and you end up with a predicted data vector called U hat, say. And then we have an error term, U minus U hat squared, or U dash. And using that error signal, we can then use the backpropagation algorithm to adjust these synaptic weights, and the network gets better. Now, this part of the model here is called the recognition model. This part up here is called the generative model. Okay, and actually that's the same generative as you know from the generative AI, but this is like, it's the simple example of what a generative model is. Or sometimes this is called the encoder, and this is called decoder, and this is the code for those of you who are in the lingo. This is where predictive coding comes from, because that's what the code is. But there's a problem, another problem, which is it's extremely hard for this to learn. There's just simply too many possibilities. We're missing something. What are we missing? We're missing some constraints on this problem. And those constraints are called priors, and they come from, let's say, elsewhere in the system. And I was at DeepMind, and we actually invented variational autoencoders, which use free energy to train these kind of things. And this is essentially how now most modern unsupervised learning happens. We're going to see how to do that, because this is extremely important. And this is going to turn out to be like how the brain does things. So it's called the approximate Bayesian inference, and it's called the variational algorithm. For those of you know that this is where variational free energy comes from. So you've got the world with some supposed features in the world that we're trying to figure out. We only get the sensory data, okay? But we can't do Bayes' inference. So what do? We have the recognition model, the bottom part of that, which is trying to be your an approximate posterior. So we're guessing, and as we grow up and through childhood, our guesses get better and better, and then we start recognizing the world. But we have an approximate posterior, which is the probability of, for example, there's a tree given my sensory data. All right, and so I get some sensory data, and that gives me an estimate of my causes that, it's a tree. And then I take the concept that this is a tree to generate what I would be seeing. That's the generative model. And then I get actual pixels. And what do I have to do? I have to compare the actual data that I get from my eyes, for example, compared to the output of my generative model. And that gives me a prediction error. Okay, this thing here is a prediction error. And I use that prediction error together with some information from priors. In other words, what I do is I compute this other term, which is essentially, I'll come back to what this is, the distance between it's not actually a distance, but it's like how far away is my estimate of causes compared to what I'm used to seeing in the world? What are my priors? For example, if I'd estimated seeing an alien spacecraft, the prior probability of that would be extremely low. And so this thing here would be very, very far away from my priors. And so it would be a very big number, okay? And so it's kind of unusual. But it might be a really good fit to alien spacecraft. In other words, the prediction error is very small. It's really good. The pixels seem to match, but it's very far away from my experience. So these two things combined give us the free energy. Okay, so that's the non-mathematical version of what we're doing. And then what I do is I use this free energy to adjust these synaptic weights, and my network gets better and better at learning. Okay, so we're learning the true posterior. Okay. Now, the reason I'm putting in some of this maths is just to show you actually how simple it really is, because the maths is really, really simple, and you just think, what is this stuff? And it's like, I hate it because it makes it sound like it's so mysterious, but it's really simple. But actually, no one in the game is going to tell you what it really means, because that's unrigorous, because it's actually kind of complicated, but it's really simple. So let me just give you this one example. I told you that there is this thing that computes the distance between two things, like the distance between an alien spacecraft and a tree. Well, so we have two probability distributions, okay? So let's imagine, and let's make this real, okay? So someone has buried some treasure along a road, all right? And there's 8 locations along the road. The treasure could be anywhere between 0 and 1, all right? And initially, I have no information where the treasure is. So the probability of where the treasure is, it's even. It's like, it could be 1/8 in this location, 1/8 in this location. It just could be anywhere along these things. So that's a uniform distribution. It's called the maximum entropy distribution, the most spread out you can get. This is very useful, because then you'll say, I really understand free energy. And then someone actually tells you, no, I will sell you some information. I'll tell you which bucket the treasure's in. The treasure is actually in this final bucket here. And that's another probability distribution. It doesn't have to be the exact, so it could have been just these final two buckets, and then the distribution would have been like that. Okay. So this is supposed to tell us what's the difference between them. And there's a really interesting meaning. There's actually a literal meaning. It's basically how many bits of information has been given to me by telling me where the treasure is. Okay, so let's do this. Let's do this together, so we know we're not being fooled. All right, a bit of information is an answer to a yes/no question. All right, that's the one bit. So let me ask: is the treasure on the left or the right? It's on the right. Okay, so that's one bit of information. Is the treasure in the first half of that or the second? Is the first half of that? No. So that's the second bit of information. So I now know here. Okay, is the treasure in the last bucket? Yes. 3 bits of information. Everyone agreed? Yeah. Okay, good. So let's calculate this thing. So that's 3 bits of information. Okay. Don't worry about that. That just means that this thing is not symmetrical. Unfortunately, it's not a distance. Distance from P and Q to P is not the same, but it's technicality. Let's actually, so if you remember this sum thing, this is the sum, right? So you do this for every one of these locations. You calculate P. This is particularly easy because P is 0 for all of this. So I just get, the first term is 0 times log of, so 0 times 0, all of these terms are 0, except for this last one, okay? Because it doesn't have a 0 in the front, because the P is 0 all the way along here. And the last term is, this is 1. P is, the probability of P being here is 1, times the ratio of P to Q. Well, that's actually, the ratio is 8. P over Q, 8. P is, yeah. So that's log 8. Who knows what log 8 is? This is base 2. So 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Okay. 3. That's what log means. It's basically doing that 2 times 2 times 2 business. And how many times you do it, that's what a log is. And that gives you 3 bits. So that gives you the right answer. Okay, just want to show you it's not mysterious. All right. So we're now going to do this. We're actually going to solve the Bayesian inference problem with the approximate Bayesian inference. Okay, what's the cause of my sensory data? I gotta get a move on. What's the causes of my sensory data? Which is this Bayesian inference, right? But I can't solve that. So what do? I have to use an approximate posterior. So I'm using a guess function called Q instead of the true posterior. And what this means is that Q is supposed to try to approximate the true posterior, truly what the probability of the features are given my sensory data. That's a huge complex function. And I'm trying to give a simple, I'm trying to parameterize, for example, this massively high dimensional Gaussian, for example, this could be Q. Now, the way I do it, simple. We know about minimizing. I want to minimize the distance, inverted commas, between P and Q. I want to minimize the distance between the truth about features, the true features of the world, and my guesses. So that's easy. So you always want to know, like, why is free energy minimized? Well, because we're trying to minimize the discrepancy between true features of the world and our guesses. Okay, so let's write out this KL divergence. Sorry, I should have told you this DKL stands for Kullback-Leibler divergence. So we're trying to find the distance between these two, and then we'll write that out, and you get exactly the same form as I had on the last slide. Okay, so that's just the definition. And when you sum up with some probability weights, that's just like taking a weighted average. That's called an average. It's called an expected value. So I'm taking the expected value. And the property of logs is that when you have log A over B, it's the same thing as log A minus log B. So that's what I've done there. And then we notice that that term, well, P of V given U, well, that's just, I can get that from Bayes' form. So if I put logs through that and substitute in there, that's just using Bayes' theorem. I get this thing here. And the point of this, just to show you how short this is, and simplify the terms a little bit. And what do I get? I get this KL divergence plus this expected thing here. And that is just a constant because that just doesn't depend on any expectations. And this thing here is called the free energy. So this thing here is the free energy. And what it says is the distance between my guess of features and the prior probability of those features. In other words, if I'm guessing that it's a tree, and actually trees are quite likely, that distance is quite small, okay? And the second term is, roughly speaking, the prediction error. It's going to be how good a fit the sensory data is to the model, to it being a tree, okay? So that's very important. So this thing here, for those of you who remember what logs look like, they look like that, and then if you put a minus sign, they look like this. So this is very, very important. So this is saying, if some data, if the probability that these data came from a tree is very, very close to 1, there's no surprise. It's not surprising at all. But if I get something like that looks like an alien spacecraft, the probability it came from a tree would be very surprising. So if something is entirely predictable, if you would say it's got a high probability of happening, there's no surprise, there's no information value. But if someone turned, I don't know, water into wine, that would be very surprising. You'd have a very low probability of that. That would give you a lot of information. So this thing here is information. Okay, it's called surprisal. And you're going to hear about surprise all the time. So you really, this is very important, surprise. And this thing here is the distance between what I'm guessing that this object is and my prior probability. So let's take this example. You see this cute little animal. I had to spend ages trying to find something like this, but I would, just for the example, let's posit that in fact this is closer to a polar bear than a dog, okay? But or let's say it's likely to, it looks as much like a polar bear as a dog, right? In other words, the KL divergence between a polar bear and this thing is the same as the KL divergence between a dog and this thing. It's actually a dog, if you tell from the teeth. But now, and just for the sake of an example, let's say that it fits both models equally well. In other words, the sensory data fits the polar bear model and fits the dog model, right? Now, what am I going to perceive this as? Well, it fits both models, but my prior probability of seeing polar bears on the streets in Tucson is very low. So I'm going to perceive this as a dog, and this is basically how approximate, which is the right Bayesian answer, actually. So this is how free energy works. And you might just ask one last question, which is, why is it called free energy? And why it's called free energy is because we can just rewrite this term slightly differently, adjusting it slightly. And those of you who know some physics would recognize that this term here is an expected energy, because this is, when I sum up with some probability weights, it's a weighted average, and that's an energy. I'll explain why a little bit. And so that's average energy, and that's entropy. which is, if you remember, minus P log P is, so that's called entropy, and energy minus entropy is free energy. This is an isomorphism with thermodynamics. So this is pure information theory. This is Shannon information. And why is that minus log probability and energy? It comes from the fact that the Boltzmann distribution, in other words, the probability of finding, if you have some box of gas in thermal equilibrium, the probability of finding a molecule with a certain energy level turns out to be distributed exactly like e to the minus beta energy. And so if you take logs of both sides and make it the other way around, then energies turn out to be minus log probability. So that's why it's called free energy. Nothing mysterious. It actually doesn't have anything to do with thermodynamics at this stage. It turns out, this is why it's so confusing. Turns out that by minimizing this informational variational free energy, you can in fact avoid the second law, the decay of the second law. You can do actions to keep you alive. So there will be a relationship, but not yet. Right. So coming back to, oh, no, we already did this. Okay. So we have this basic idea of what's going on in the brain. Yeah, can I?
When predictive processing talks about minimizing prediction error, is that minimizing free energy or minimizing?
So minimizing prediction error is basically to dumb it down for people, because half of it was prediction error, that surprisal part, but the other half was the KL divergence. So, yeah. But it's no problem. It's like you get a long way. Just think of it prediction error. Wouldn't worry about too much. But it's really, this prior story is really important. It's really going to be important in terms of how the brain works. It's really going to be important how meditation works, and it's going to be very, very important in terms of awakening.
So it's not just prediction error; it's your prior.
Yeah. So we so I don't want to dumb. That's why we cannot dumb this down too much. So we got this excellent model from machine learning, fantastic, which is like making sense of the world, except that's not how it actually works in the brain. The best model that I have for how it works in the brain is this. What we do is we take this generative model and then fold it back down on top of the recognition model, all right? And this is an amazing thing. This was something that I when I first came across this, I like put this, and then later on, the luminaries like Carl Friston says, "Oh, that's excellent. You'd never thought of it like that." But actually, this is why it's a really good way of thinking about it. And what you find, there's always been a mystery. 20 years ago, most people thought the brain works by like taking in data from at the low levels and processing it up, and at the high levels in the cortical hierarchy, I figured out what's going on. And it's like a feed-forward network. But guess what we found? We found that there are roughly like an order of magnitude, like 10 times as many feedback neurons in the brain from top to bottom than feed forward. And that was like a mystery until we figured out that, in fact, we just didn't understand really what's going on in the brain until the last 10, 15 years. And so what's happening is that we have this feature layer, and it's sending down, a generative model down here, right? And in fact, thinking about it, no need to send the data up. You only need to send the prediction errors up. So here's the thing. We don't actually even use the sensory data that we get to make sense of the world. We're only using the prediction errors. What's really going on is that we've got this generative model that's guessing what's going on, and we're just using the prediction errors to adjust the dials and knobs of our simulation of our generative model. Okay. And now you might ask, well, now, you use priors for this feature layer. Now, where do these priors come from? Well, they come from another model higher up in the cortical hierarchy. And these priors, sometimes in neuroscience, they're called beliefs. Okay, and they are beliefs. That's another good word for prior, really. And prediction errors go up here. And where do those priors come from? They come from another layer above. And how many are there in this cortical hierarchy? No one knows. But, something like half a dozen or maybe more. Okay, so that's hierarchical predictive processing. Very, very important for what we're going to be doing, because in meditation, we're really deconstructing that one layer at a time. Now, more stuff. Oh, but this is important. This is going to be absolutely critical because, I need to give you you all know about serotonin and noradrenaline and all this kind of stuff, but where is it coming from and how is it linked to this predictive processing stuff? This is the closest thing we have to exactly how those neuromodulators work. So there is a very nice approximation to this free energy principle we have if we assume normal distributions. They're called Gaussians. You get something called Laplace approximation, which is really nice because it helps you understand what's going on. And what it says is that if I have this is where the treasure is buried on the road. If I have some prior beliefs around where the treasure is buried on the road, and if I have some sensory evidence from my eyes, like I get some evidence, or I think there's a lump there, and I don't know, some fresh digging over there. Where do I dig? Well, I actually dig. Where am I going to perceive the treasure is? This is where we're going. You form a posterior belief, which is some sort of combination of the two. And the way you combine it, I'm just going to give you the means, just to combine the means. Okay, the way you combine the mean of your posterior, so this is where you think the treasure is buried, right? Is you weight the mean of your prior and the mean of the sensory data. In other words, you take an average. You take an average of this and this. But what are the weights? It's not a 50-50 average. This is a weighted average, okay? And this here, this is absolutely crucial. This is called a precision weight because just so you know, precisions are the inverse of variance. So when this thing has a very low precision, it's got a very high variance, right? And this thing has got a very, it's low variance. So high precision is 1 over the variance, okay? So that's, you basically weight, you take a weighted average of the prior and the likelihood of the data, but it's weighted by how precise the prior is and how precise the, that should actually say data, sorry. Okay, so for example, I could take a 75% weight for the prior and the 25% weight for the data. So your posterior belief, a weighted average of your prior and sensory evidence, okay? And this is very important because we're going to come up with the first bridge to phenomenology, which is what I call the neurophenomenological hypothesis, which is the posterior is what you perceive. We don't perceive priors, we don't perceive sensory evidence. It just shows up. We're just seeing a dog or a polar bear or a tree, okay? And it's preformed. We don't have access to all of the underlying stuff in general. So this is the neurophenomenological hypothesis. What I may experience is the prior. In other words, actually, we may not be conscious. There's just a little caveat I have here. We may not be conscious of all the generative model. So that's why I put this little may in there. Okay, now, this is important. So let's say now that I have a much increased precision. So before, it was a foggy day. I couldn't really see what was going on. Now I can really see what's going on. What happens? The posterior shifts closer to the sensory data away from the priors. Okay, so, and what happens if my priors are very uncertain? Then again, the posterior will shift closer to the sensory data. So I'm going along the road and I see this furry animal and it's really foggy and misty and it looks like a lion. But my sense, fits the data of a lion, quite well, but the model of a lion. But but my prior of seeing a lion is very low. But so I'm going to perceive it as a big dog. But now it's a clear day and there really is like this lion thing. And so even though my priors of lions on the road is very low, I will perceive it as a lion because the sensory, there's a much more higher precision weighting of the sensory data. Now, why do I go on about this, these precisions? Because one last thing. Okay, I'll do this example first. So just to bring this let's imagine a game of tennis, right? Someone serves and there's a return, and the prior distribution of someone of this person, your opponent, is that they like to hit down the line, okay? And you get some sensory evidence that actually it looks like they're hitting in this region. Where do you run to? You actually run to, well, something like this. And actually you run to something closer to the sensory evidence because that actually has a lower precision. It's tighter, it's smaller than this big prior. Yeah. So this is basically how it will work in a game of tennis. Right. So, and I just want to say that why is this important? Well, these precision weightings between these layers, which I'll come on to, actually map onto the neuromodulators. So things like, serotonin and noradrenaline and acetylcholine may actually affect these global precision weights. And we're calling them precision weights, but then just use it as a term of art, because in fact, we have all these global mechanisms that are interfering with this precision weighting mechanism. So you can just call it a weight. Right, let's see how this works. Okay, so I got this blurry face here where the edges are not very discernible, it's dark. Okay, that's my sensory input data. That goes up and from my so I've got some priors around what a high level representation, what would a face prior be like. And that gives me a generative model, but I get prediction errors from this actual face, and that adjusts the generative model until I get the output of the generative model, which look, it's got all these faces filled in. And that's what we're doing. We're just filling in all the time. That's exactly how perception works. And the computational neurophenomenological hypothesis is that this is the face that is actually experienced. I do not experience sensory data. I do not experience my priors. I experience the output of the generative model. Right, this is important. We are experiencing the output of a generative model. We're living in our own simulation. All right, I think I've already talked about this, where you have precision weighting between priors from the layer above and prediction errors going up. Now, let's look at the brain. Okay, so we talked about these models here, low-level models, mid-levels, high levels. We said about like edges and corners and noses and eyes and like faces. What is the actual hierarchy in the brain? Well, we have a really interesting piece of analysis here. This is 17,000 fMRI experiments that were done. And using neurosynth and there's a machine learning analysis to figure out the cortical hierarchy. It's quite a complicated thing, but let's just look at what it really saying. Right down at the bottom, we got the somatosensory, basic sensations, prosodic, that means like kind of the basics, the sounds of like the actual vibratory sounds, the vibrotactile things down here. Very low-level sensory data. For those of you who meditate, this is the level where you might feel piti and energy. And then, as you go up, you start seeing motion and rotation, and then, faces, and then right at the top, we get concepts and language and reasoning. And so what we see is a kind of an abstraction. It's actually a compression that's going on up this cortical hierarchy. So we're extracting higher level features as we process, right? From low level to mid level. And you know, these are the kind of features that we are extracting. I really got to get a move on. Okay, just one last few things before we get to. So if that wasn't enough, that perception this is how we generate perception. Turns out that the whole of action, everything we do, is actually also in the same framework that minimizes free energy. And this is astonishing. Our goal states are actually priors. So how does it work? It's like, I want to get this, imagine this is an apple. I want to get this apple, and my hand is here. And but like my prior is that I would have the apple, I'd have the reward. And so I got a prediction error, okay? And I want to minimize prediction error. I want to minimize free energy, so minimizing prediction error. And so I take the apple. And so we have this absolutely amazing, harmonious, like unification of the general theory of neuroscience. Before this, we basically used to use reinforcement learning, but now reinforcement learning has now been subsumed within this larger framework. So this is very parsimonious framework. And this will become important because we're going to be talking about suffering. Okay, now we've talked about all this perception, but we kind of missed something really important. You know, we talked about like perception from the outside. Let's call it exteroception, external perception. But actually, the most important thing is our body. In fact, our bodies are like deeply priors, deep weighted priors. And we have now you might think this is very strange. The brain is enclosed in this bony scalp with these neurons coming in, maybe some neuroendocrine system, systems, but it doesn't know what's happening. It also has to make a perception, what's called an interoception, internal perception, of what's going on in the body. We need to regulate our body. Think of homeostasis. It's a general word called allostasis, which is homeostasis, which is appropriate in a particular situation. So, you might say homeostasis is keeping my heart rate at a certain level. But actually, when I'm running away, when I'm really fearful because there's a tiger there, my heart rate should be higher. It should be, because it's going to prepare me to run. So we have interoception and actually visceromotor actions back, through the autonomic nervous system and the neuroendocrine system. And these come together in some sort of multimodal integration. And again, predictions and action loops, because predictions and actions now are under the same rubric. And then we have a high level priors about how the world should be. And so this is really a general picture of what's going on in the brain. In fact, I'll now show you what I think is the best picture of the brain that we currently have. And that is like this, that we have low-level models at the bottom, middle levels, high levels. So we have all these unimodal streams of processing. So we have the somatosensory stream, body sensations, interoception, which is feeling my viscera. Okay, somatosensation is feeling like, what my body sensations are, interoception. Then we have visceromotor, which is actually an output to the autonomic nervous system. Let me get stressed, let me have some adrenaline, let me adjust my neuroendocrine system. We have proprioception, where my body parts are. We have vision, the visual cortex. Of course, that's like, the lion's share of what's going on. Audition, gustation, olfaction, taste, smell, and then another output, which is the motor system. So moving and making actions. But that's not all. So this is the principal gradient of cortical connectivity. I'm going to have to move faster. And this is unimodal processing, but at higher areas in the brain, we start getting this massive multimodal integration where regions start talking to each other. And right at the top, and not at the top, just right throughout, are the things that really are going on, which is large-scale networks, like the default mode network, the central executive network, the salience network. These large networks which kind of are multimodal and sit at the top of the hierarchy, and actually, in a sense, like the default mode network, right at the top of the hierarchy is where the home of the predictions and priors are really going to be. They're where the multimodal summaries are stored. Now, oops, there's something missing there. There's something missing. Where is the self? Like, I mean, that's an interesting question. I haven't talked about the self. Where is the self? And we're going to see that these, the hyperpriors like space and time and the phenomenal self-model priors are all going to be in the higher areas of this multimodal integration. That's what we're going to see. We're going to need to actually, as a part of this construction, create a self-model. And within, okay, let's first talk about the fact that we need to have all these experiences, but they need to be happening to somebody. We need a sense of where we are and where the tiger is. Okay, we need a certain perspective on the world. We need to organize our sensory data so around a self, because that is the most economical and parsimonious way to make actions that are conducive to our survival. And this, this phenomenal self-model that we have, something very interesting about it. It is the seat of multisensory integration. There is a sense of agency as a part of this self-model, which is that I am the doer. Of course, all these doings are just happening. There's just processing in the brain. But there is this, as part of this phenomenal self-model, there is a sense of agency. There is an experience of mindness, that this is, that these are my limbs. There is, as I said, an experience of perspectivity. And then the most important is that there is phenomenal transparency. So what does that mean? If you see this bird, you say, oh, what a lovely bird, sitting there on the tree. What you don't realize is that you just hadn't seen it while you're looking at it. You're looking through a window. And when you notice that you're looking through a window, suddenly the window becomes opaque. The window is previously transparent. Now, the window represents the models that are used to construct our experience. So that window is generally transparent. It's very useful because it would be, well, for evolution, who knows why this illusion, I mean, there are deep reasons why this illusion happens, I think, to make us take our life very seriously. Take your life seriously and survive. But suddenly we can become aware of this window and it shows up as opaque. And Thomas Metzinger, way back, actually proposed this, that if we became fully, if our self-model became fully opaque, the phenomenal target of experiential selfhood would disappear. In other words, we would see through the illusion that this self-model is constructed. Okay.
It's not intuitive to me why that's analogized to being.
Oh, okay. So no. This is important because I know meditation. So in my book, I'm actually using a different. I'm using M opacity and M transparency. It's going to confuse every meditator because our experience is exactly the opposite. the window is transparent. You're not like seeing it. You just like not aware of the window, and then suddenly you get you see the window pane, and it kind of like, there's a window pane there, and so we'll call it opaque. Unfortunately, this terminology was introduced by a philosopher called G.E. Moore in 1899, right? Okay, so we're going to have to live with it. However, I would say that I'm going to propose using something called M opacity to describe this for Metzinger-Moore or model opacity, and M transparency. And the reason why I know why you are intuitively feeling, no, I don't like this, is because here's the funny thing. When we make our world model opaque, it actually feels phenomenologically transparent. Okay, I know exactly where you're coming from. It's exactly, and when the world is really real, it feels opaque. So it's the wrong way around. Okay, but okay, let's carry on. Let's take. I'm really running like it's like an hour in, and I'm not even like. Okay, so neurophenomenology. Okay, so we have our generative model. Okay, and I'm looking at the tree. Okay. And there's all these thoughts going on. Like there are all these thoughts in my generative model. So and what else is in my generative model? Well, visual thoughts and auditory thoughts, blah, blah. And, a sense of my viscera and somatosensation. There are smells, a sense of the breath at my nose, has my heartbeat, I can feel sounds in the environment, and all these emotions. Okay, all right. So, but where's the self? Well, these are organized into a kind of phenomenal self model, which has part of it is agentic action. There's a kind of subject-object duality that's set up in the phenomenal self and the object. There's a perspectivity, there's an experience of mindness. So there's this whole sense phenomenal self model that's layered on top of our raw experience in our phenomenal generative model, in our generative world model here. And the question, okay, so then the question is, what psychotechnology do we have to opacify the phenomenal generative model? Can we leave it to the end, or unless there's something like, yeah, okay. What psychotechnology do we have to opacify the general model, the phenomenal general model? That's what we need to do, because the model is transparent to us. We think we are really seeing the world. We think, yeah, really, I'm here. And of course, we do have some psychotechnology, meditation, psychedelics, other practices. There's a whole ecology of practices out there. And let's look at meditation. So this is my attempt to kind of synthesize all these practices. It's taken from some initial work done by Antoine Lutz and others, and this is slightly different. But essentially, I'm gonna like, there are hundreds of ways of going through this journey, all right? And I'm not gonna give anything. I'm just gonna take a random smattering of some focused attention and some deconstruction work, because we're gonna be trying to talk about awareness, all right? But just to give you a little sense of what this is, we have focused attention here, you'll be open monitoring, object side open monitoring, choiceless awareness, shamatha without an object, subject side, investigatory, like Vipassana and insight meditations and Zen koan practice, analytic meditations, Dereification of specific models, that will be there. Jhana meditations, which are slightly deconstructive, but mostly shamatha, and loving kindness and other deity yoga, more constructive practices. We have resting as open awareness, non-dual open awareness, shikantaza, just sitting, Advaita Vedanta practices, Sufi meditation, non-meditation in Tibetan Buddhism, and a direct path. I really have to speed up now because it's so focused attention meditation. So what's going on here? We are told to pay attention to the breath at our nose, for example. What we do, attention, if you remember, the homologue of attention is precision weighting, okay? So we increase precision weighting to these sensory data here, to these models here, and decrease precision weighting everywhere else. Why decrease? Well, because precision weights have to add up to 1, okay? That is the weighted average of our model. In other words, what we're doing is we're shifting our posterior distribution, we're shifting our experience closer to the sensory evidence. Okay, and what that does is means that in our gestalt, in our conscious gestalt, the breath is prominent and everything else becomes less prominent. Okay. So that's good. Okay, so now it's like we've been sitting for an hour. Let's do this. Let's just get out and like take a breath, and then we'll start again. No, because now we're going to get on to the really good stuff. Because okay, let's back in. All right.
Yeah.
Okay. Stephen. Okay, back in. So focus. Okay, so now we're really in the running, okay? So focused attention, of course, trains attention awareness, gives you meta awareness. This is not really going to be about meditation, okay? So there's lots of stuff I could focus on. So I want to get onto awakening. So we have deconstructed meditations, like, for example, like Vipassana and some sort of Mahamudra stack. And what in deconstructed meditations, essentially, we're unfabricating experience. So we saw how experience was fabricated. Okay, we saw how it goes from the basic sensory data, raw sensations, all the way up to concepts, to thoughts. So in deconstruction, we are now unfabricating. And what we're doing is, I guess that, like, well more than half of you are like meditators, so you kind of know this stack. But how to deconstruct things into RGB pixels, for example. That was not a very good resolution. What's going on there? What we're doing in that deconstruction process is reducing the precision weighting of these top-level priors. Okay, so this is really important. So when after some serious meditation, for example, you may get this idea that your body map, which is kind of a high-level thing, starts becoming less prominent and, in fact, might disappear. And what you're left with is this vibrotactile kind of energetic sensations, which are low-level sensory percepts. And so we are descending the cortical fabrication hierarchy in meditation. And we are deconstructing, but at the same time as deconstructing, I'll come to this a little later, we're also dereifying. Because if we thought that the body was like so important and then suddenly it's like disappearing, it's maybe it's like not real. So we'll come back to dereification, but I just wanted to say it. And then we get, in our generative world model, we get a kind of generalized opacity and a deconstruction. And with our shamatha, with our quietening meditation and focused attention and other experience, everything is quiet and has low precision rating. And at that stage, there can be a recognition of the empty space of perceptual experience itself, the actual space of the generative model. There can be this noticing of that perceptual space, and that is the first recognition of non-dual awareness. And this basic substrate on which the generative model arises has had these kind of traditional metaphors. It's like a mirror and its reflection. It's like the screen. This pink area is like the screen on which perception is arising. It's like the sky and the clouds, actually, because these are still clouds here. Or it's like the ocean and the waves. These are still some waves, although less after this quietening meditation, or a field in its vibration. And this is a very important recognition. This kind of non-dual awareness has had many names across these millennia. Consciousness as such, pure consciousness, pure awareness, Rigpa, Tibetan Buddhism, timeless awareness, timeless choiceless awareness, or Satchitananda, being consciousness bliss, the capital S self, Turiya, the fourth, Brahman, Buddha nature, the clear light in Tibetan Buddhism, the ground of being or the groundless ground, emptiness, the deathless, the peace that passes understanding. And what you can notice is that when you come back, you can start after a while to recognize that it was there all along, this space of the generative model. That, sorry. That's it. Oops. The space of that very good. The space of the generative model, and not just that, but now, once it's back, I'll come on to more of this later, but everything that's now being reconstructed back again comes back with a different quality, a quality of Dereification. Now that we've seen the joke, the punchline, we can see that there's more of a kind of, we can see the constructed nature, the fact that it is a, some people talk about it like a dreamlike quality. Recently, Thomas Metzinger has done an amazing job, and if you guys haven't seen this amazing book, The Elephant and the Blind, I would really recommend it. He talks about the minimal phenomenal experience and has interviewed a couple of thousand, well, there's 500 meditators in there, advanced meditators, and he has termed this word, which I like very much, called the epistemic space, the knowing space. But terms like presence or pure being, luminous, empty, openness, it has an inherent reflexivity, an awakeness, a spaciousness, silence, stillness, timeless. And one thing to notice here is that all these traditions actually report us very similar phenomenology, but quite different metaphysics, and we'll come back to that. And then just a little bit to say that, let's not reify this awareness itself, because one of the qualities of that epistemic space is that it itself is dereified. It's not a thing. Now, what are we seeing here? We are seeing the fact that this kind of a waking up to the generative model itself, to the substrate and the modulations of the generative model has been around for a long time. And Plato had a particularly beautiful analogy. He talks about these prisoners are stuck in a cave, and there's this sort of they see these flickering shadows, but they're not seeing things in themselves. They're just seeing these shadows. And of course, one philosopher goes out and sees the real world as it is, and then there's a whole thing no one believes in. But what we are seeing here in the generative model is really of Plato's cave, as people have put it. So let's talk about this Dereification quality. So let's take two things. When things are reified and things are dereified. When perceptions, thoughts, feelings, and the self, it feels like you have direct contact with reality, some sort of inherent existence, seeing the world as it actually is, objectively existing from its own side. This is reification. And dereification is when it's seen as a mental construction, it's mental fabrication. It's a controlled hallucination. Things are made of consciousness. Okay. This term, of course, in Buddhism is generally described as emptiness. And we could say that this reification is what in philosophy is called naive realism. It's kind of common sense realism that, I'm really seeing things as they are. And again, using this transparency, when the models are transparent, I've used this M transparency because it's reified. And when I have M opacity, model opacity, things become dereified. And the phenomenology, interestingly, when objects are perceived as substantial, solid, when they're reified, fully formed, unquestioned non-virtuality, and sort of opaqueness wins both, right? And on the other hand, when they're dereified, they become ephemeral, diaphanous, shimmering, translucent, dreamlike qualities, sort of transparent, insubstantial, and spacious. So this is kind of some of the phenomenology. So let's look at this. Let's look at the phenomenological dimensions of meditation. Okay, the first dimension is reduced phenomenal content. In other words, calming the mind, quietening the contents of experience, right? The second dimension is deconstruction, descending the cortical hierarchy. And then the third dimension is dereification, emptiness, or pacification, recognizing the empty space of phenomenal experience itself. Okay, so we start off in monkey mind, right? Which is kind of, pretty busy, lots of content, very constructed, very fabricated, and really real, really, really real, all right? And as we meditate using concentration, say focused attention, a novice meditator may quieten to some extent the contents, and then advanced meditators, expert meditators may quieten even more with focused attention. Deconstructive meditation would be descending the cortical hierarchy and also quietening. And this is sort of a novice, say, Vipassana meditator. And this would be a more advanced meditator where there's a substantial descending the cortical hierarchy, deconstruction, defabrication. And at the same time, you notice that the more deconstruction there is, the more dereification there is. And that's important. When you deconstruct something, well, it's no longer real. And when it comes, especially when it comes back, and then finally, we can have a very deep, non-dual absorption state, minimal phenomenal experience, something like a nirvikalpa samadhi, a pure, or even, we can have discussions around, cessation is slightly off the map, but open non-lights out cessation, and where things are very, very deconstructed. Now, you might think, well, that's the end of the journey, but it's not. Because that's not where the journey ends. The real journey ends when you can then come back into busy, full, busy mind with lots of construction refabricated and yet dereified. And in the words of T.S. Eliot, before quartets, the end of all our exploring will be to arrive where we started at and know the place for the first time. And so we come back into form, back into life, and come back, but something is subtly different, which is that we have a fully constructed and yet dereified form. Now, I want to emphasize this distinction between dereification and deconstruction, because previously people have run this word together, and especially in fabrication. So fabrication, if you notice, fabrication has a dual meaning. When something is made up of other things, it's fabricated, and when you unmake them, you can deconstruct it. But fabrication also means, oh, he fabricated. It's a pack of lies. Yeah, do you see that double meaning? So that's one of the things why I think it's been, it's very important to do this. I really don't have the time for the jhanas because I need to get on, but you can do the same journey in terms of jhanas. And I'm not going to go through this, but this is something I'm really working on here, which is deconstructing all the models, thoughts, emotions, body sensations, right down to subject-object duality, central consciousness, inside, outside, space, time, agency, what happens with pacification, what happens with deconstruction, a negative terminology, not this, not that, and then some sort of positive, for example, like time would be, timelessness would be unfabricated here, or eternal would be the positive terminology. And yet, when it's dereified, it's subtly different. It's like change and impermanence are arising within awareness. Okay. So suffering. Let's quickly get on to suffering. I'm going to miss this. So basically, what was our theory of free energy? Free energy, because of this action cycle. So we need to do actions to maintain homeostasis, right? And our priors are that we'll be in these homeostatic systems. Moving towards minimizing free energy is associated with positive affective valence, okay? And so in other words, means you'll continue the action, and moving away, increasing free energy would be unpleasant. So and therefore there will be counter-regulatory action. There will be negative affect. Now, existence is full of negative valence. So this is like, imagine this massively high dimensional, aka 3, but like massively high dimensional surface, which is expected free energy, but you can think about it as a negative value function, or the negative of rewards, or a machine learning loss function, or something like that, deviation from homeostasis. And what is this? Well, there are deviations from the local minimum attractor basin here, caused by surprising fluctuations in the environment all the time. These deviations, i.e. frustration of preferences, of where your preferences are negative valence, and they spur action into counter-regulatory action, so to minimize that deviation. But the stochasticity of the environmental fluctuations is inexorable. That's just the way life is. And therefore, any system with preferences will inevitably be characterized with continual bouts of negative valence. That's just the way the system works. That's just the way this free energy principle works. And interestingly, that's basically Buddha's first noble truth, that life is full of suffering. So, very quickly. Imagine we have some phenomena that arises from this unfabricated substrate. As soon as that arises, there is a prior associated with how these phenomena are to be, and there's automatically a prediction error that arises, a negative valence. And of course, that prediction error there could be mental proliferation around that prediction error, which leads to further, and you can get stuck in a spiral of papancha. Now, what happens? So let's look at what are these conditions of suffering. So this is Thomas Metzinger's 4 conditions of suffering, which I think are pretty good. The first is that there is negative valence. Okay, that something is not how one wants it to be. The second thing is, this is more for AI, but that there is consciousness. The third is that there is a phenomenal self-model, that it's my suffering. So if there's a suffering, like, okay, but it's my suffering, I've got to take it really personally. And the fourth is that it's real, that this suffering is real. This is not just playing a game of Monopoly. This is not just some scoring system. I take this really, it's seriously, and it's real. And what do we talk about? Well, we have a way of deconstructing that, but also, like, you can do either one. You can see that this is actually not real, that the opacity, you can see the opacity of that, opacity of that. So essentially, emptiness of the phenomenal self, dereification, reduction in mental proliferation, reduction in gripping, reduction in craving, and that all comes from this dereification, this emptiness of phenomena. So now for the good stuff. Okay, we're in this final stretch. So after we deconstruct ourselves, we reconstruct ourselves, because we do. It's not that we just say, "Oh well, my phenomenology has changed and that's it." No. We are able to attenuate our priors. We have now got mental action. We can now go into ourselves and actually change, because we've reduced the weighting of our top level priors, and we're able to do that. We're able to enter into reprogramming mode. And this is phenomenal. We can upload a new operating system. We can upload new ways of thinking, new priors. You can do like skillful fabrication, like Yidam practice. Okay, so this is also similar to what happens in psychedelics, when we think what happens in psychedelics is that you essentially flatten out the free energy surface, and therefore are able to go to different attractor bases. I'll come just, but this is this bit's important. Dependent co-arising is Bayesian inference. So what have we learned? We experienced that the world is a construction, but it's a constrained construction. Okay, it's constrained by external data and internal beliefs and priors. And the trick is to make it beautiful. So we have external data, but we approach it through a way of looking, high-level priors, high-level beliefs and models. And this dependent co-arising comes together in the 2 terms of Bayes' theorem, okay, the priors and the likelihood of the data given my priors. And that generates my experience world. So what I experience is comes from the sensory data and the way of looking, as we've just seen. Okay. Now, so for example, this is the example I really like to give, which is like, if I'm a depressed person, my high level priors is that I'm a rubbish person, the world's a terrible place, and everything always goes wrong. Okay. And I look at the data and I see, the glass is half empty. It's terrible. Like it's gone wrong. My experienced world confirms that the interesting thing is that the likelihood, the sensory data, the probability of the sensory data given that the world's a terrible place is high. That model fits. And therefore my experienced world will be that it will be the glass half full. And the key thing is that we have Bayesian feedback. So I had this prior, I looked at the world, it confirmed my prior, and it strengthens my prior. So I get stuck in my way of looking, right? And that is a problem. So let's say, for example, but not every belief is like that. Some beliefs are just not good. For example, my prior is the world is made of cats. Okay, that's a pretty bad prior. So I say, like, I start with this: the world is made of cats, and I go, okay. Well, I look at the world, and actually, the likelihood of the data, given that it's cats, the data doesn't fit the cat model, and therefore my experience world will be less cat-like, and therefore I'll adjust my prior. So I'll start with that cat prior, and I'll get a new prior. Well, it's kind of less prior, less like cats, and then I'll do that again, and then again it'll shift, and I'll keep doing that until you get the prior feeding back to itself, and that is called an attractor. Okay, that's a stable attractor in the landscape of priors. That's a stable attractor in the landscape of beliefs. Beliefs that are stable are local minima in attraction basins. Now you might say, well, what's that about? Well, there can be several of these. It's not just one universal truth that, like, a belief structure that, like, reinforces itself. There are many belief structures that reinforce themselves. Okay. Like the world's a terrible place, or the world's an amazing place. It's like a gift. It's a miracle. See, like, look at this. Look out there. It's amazing, right? So we have these attractor basins that we can move into. And what I'm now going to talk about liberation really which is this reprogramming of our top level beliefs and priors. So first we deconstruct by a series of meditation. We go down to this minimal phenomenal experience. And as we deconstruct, as we go into reprogramming mode more and more often, we are able to reconstruct our priors. And here's the interesting thing. We can reconstruct to different locations, okay? If you are within a lineage that says we're going to train you up in loving kindness and the Brahma Viharas, and you're going to, like, and then, guess what? You get what you trained for, and you're going to reconstruct there. You go into another thing, and we're going to, like, do awe and reverence of the universe as Sufi love. Wow. And that's what we get, or Christian love, or different locations. You will find that there will be different priors that we can train up, and they will have these commonalities, but there will be also differences. And so what you can see is that many spiritual traditions will have a similar experience at the minimal phenomenal experience, but different endpoints in this kind of path, which will be probably correlated. Okay, so we've got these two dimensions that we've been talking about, awakening and liberation, right? So we start off by saying having an initial awakening, and that means you wake up to the essence nature of your reality, that that gives you more room between stimulus and response, that allows for extinction. Essentially, if you have a certain pattern of behavior, and you no longer you have more room between stimulus and response, you no longer have to respond in the same way, and we go through something called extinction therapy, which means that those patterns get extinguished, and you can think of them as samskaras or karmas, but from a modern kind of neuroscience perspective, you would think of it as extinction of patterns that are no longer being reinforced. And having more of that patterning allows one's awakening to broaden. It's not that it changes, but it broadens into more situations that would have previously been triggering for you, for example, right? And so then you broaden your awakening, which means that you get more and more liberation, and you get this kind of interesting process. Now, there are a couple of ways that you can go through this trajectory, which I kind of just want to highlight. There are these two very interesting paths. One is this direct path, which is kind of awakening up front, into the non-dual, and then this long process of extinction. And one is the progressive path, or which is very purification heavy to begin with, but then once the awakening gets going, it really gets going. And the idea is that there may not be any shortcuts in this process, but it's kind of that's just a stylized picture. The main thing to see is this relationship between awakening and liberation. So I'm just wondering whether to really take this mystical leap. Huh? Should we have a vote of like a mystical leap? Anyone mystical leap? Yeah? Yeah? Okay, good. This is where mystical leaf is okay, Shinzen?
I want the red pedal.
Okay, right.
It's the attractor that you're inevitably having.
Right. Okay, now it gets really interesting. Now you think you've been freaked out so far. Arthur Schopenhauer was followed with Kant. And there's this brilliant piece from one of his works, The World as Will and Representation. Will, you can think of as the ground of being, pure awareness, and the noumenon, and this is the phenomenal representation. We shall never get beyond the representation, i.e. the phenomenon. We shall therefore remain outside of things. We shall never be able to penetrate into their inner nature and investigate what they are in themselves. So far, I agree with Kant. So that's kind of the predicament that we find. How do we get into reality as it really is? But now, the counterpose to this truth, I have stressed that other truth. Now, as a counterpose to this truth, I've stressed that other truth. We are not merely the knowing subject, but we are that we are ourselves amongst those realities or entities that we were required to know. We are ourselves the thing in itself. So, we're trying to find the thing in itself. What is this table in itself? What is reality? But we ourselves, the knowing subject, are also the thing in itself. That epistemic space that we talked about. Consequently, a way lies within. A way from within stands open to us that as to the real inner nature of things, so that we can penetrate it from without. So to speak, a subterranean passage, a secret alliance, so that we can take the fort from within. And this is amazing. So what does this say? So what this is saying is that maybe we got it wrong. So far, we've opened up to our generative model. We've awakened to the nature of our experience. But that experience itself, or the substrate of that experience, is part of reality. So that brings us to metaphysics. And given the time, I'm not going to focus on this. Obviously, that particular thing would be that everything is made of pure awareness. Everything is made of consciousness. But in fact, actually, it roughly means that everything is one. Everything that is going on is one. So I won't focus on this because I'll bring it in together. I don't have time on the metaphysics of this. I want to get onto this Markov blankets. This is important because, okay, so there was this high road and this low road in this free energy principle. And so far I've taken the low road, but now I'm going to shift to this other perspective, and it's amazing. And it's a perspective not from self, but from world. And what is this whole awakening project? We're just like looking at this, like, I want to wake up, but we're maybe looking at it upside down. So what's really going on here is that, okay, so I won't get into the sort of details of this Markov blanket, but roughly speaking, we have there is just the universe that's going on. Okay, there are external states, what we can call, and then some internal states. What defines an internal state? So, how do we differentiate there's just the universe, like, so what makes it like internal states and external states? Well, there's this information theoretic thing called a Markov blanket, which is an informational blanket. And roughly speaking, what it says is that internal states are ones that are shielded off by what are called blanket states. These are sensory states, these are action states, but let's just, in other words, you have the external world, okay? This is all really this is all just the world, but you have the external world, and if they go through, if there are some states that only have access to these other states via a blanket. Think of it like a cell membrane. So think of a cell, okay? This is just an analogy. I mean, don't take it physically. This is an informational space, okay? But like a cell is a good idea. So on the inside of the cell can only get information about the external world via the cell membrane, okay? Every piece of information about the world has only entered, is somehow encoded onto the blanket at some time, right? And then you can define what is called internal states. Now, there is something amazing that could be proved, and this was proved probably like 5-6 years ago. An amazing thing, but it's been around for probably 10-15 years before that. But the proof is this: if a Markov blanket this is some sort of universe, right? This is actually a simulation. And if there is a kind of a Markov blanket and there's some internal states, what you can show is that those internal states, that everything within the Markov blanket must have a model of its environment to persist. So this was an amazing proof that this says that if a Markov blanket persists in time, continues to exist, defies the second law of thermodynamics, and actually does not degrade, so the assumption is it's continuing to exist, then it must, in one way or another, effectively have a model of its environment, which is what we saw. We have an internally constructed model of our world and ourselves in our minds. But this is a generalized theorem which starts from just the universe to begin with. And so that is amazing. And I'll tell you one more weird thing, which is going to make you really think. This is just purely mathematically. The environment ends up having a model of what's inside as well. Like, this is like really interesting. So you can think about evolutionary niche theory, about this stuff, but this is very deep stuff. Anyway, what I want to show is this. So I guess you can see that these are all connected informational cells. Somehow, a Markov blanket, through some sort of miracle, through evolution, whatever, starts to exist. We have a Markov blanket. And let's just think about this. There is just the universe going on. But in this Markov blanket is a model of the external universe. And it now has to think that it's separate. This is almost like Bernardo Kastrup's alters. And what's more, we have lots of Markov blankets in the environment, lots of things. And each one of them has a little model of the whole. Look, you can see this, but this is like a model of the whole. And each one of them has a model of the whole. And what you get is this very different perspective, which is, I'll tie this into the priors later. But now that we're liberated in seeing the world in different ways, we now see that we have a model of the environment. But really, what's going on here? What's going on is that there is just the universe, and there are perspectives. This is just also the universe. And there are perspectives of the universe onto the universe. And this is another perspective of the universe onto the universe. And of course, you might say, well, it's localized and all that, but it's not really localized. I mean, like within a space-time thing, it took 13.8 billion years to kind of, make all this and us, and, we're all, so there is just the universe that's going on, and there is a perspective of the universe onto the universe, and there are trillions, quadrillions of these perspectives, every insect. And so there is this very different way of looking at that same empty experience, which has now been freed. We're still our priors are still thinking about this self, but actually, as they liberate up, we can see that, well, what's really going on here? There is just the universe unfolding with all these different perspectives, and we are just these perspectives. And so, you end up with this very different perspective. And I just, because I'm really pushing it, but we end up with these three traditional levels of awakening. Level one was what we spent a lot of time doing, and I really, I don't apologize about going into this free energy stuff, because it is going to be like this foundation of this whole thing that's going to be coming up, which is that we're waking up within our phenomenal generative world model, becoming lucid within our own constructed matrix, okay? Waking up to our own awake awareness. But that, I call that the Atman level, the kind of the true self level, the soul level, if you like. But that awakening, and it's beautiful, and actually you'll get huge changes in morality and all sorts of things from that. So it's great, right? But there is this other way of looking at it, the same awakening, actually, which is there is only one substance here in a philosophical sense. Substance, there are two substances in dualism, mind and matter. But there's only one substance, and people have called it different things: reality, God, universe, nature, whatever. There's just this one substance unfolding. And that I like to call the Brahman level. It's not quite right. But here's the important philosophical term. This is really pantheism. Pantheism means everything is God. Okay? Everything is the one, everything is the one substance, reality. Like the word God, you use universe, reality, whatever. Okay? But everything is one. And then there is this third level of awakening, which is even beyond that, which is that this reality is just one tiny manifestation of a pure, formless, unmanifest absolute. That pure epistemic space that we were tuning into level one, that is so much more. That is so nothing, absolute nothing, which is pregnant with all potentialities, the infinite. And that this reality is just not even a bubble of froth on the sea. And that level I call the Tao level, the infinite, the absolute. But technically, philosophically, I just want to say the important word here is panentheism, which is not that pantheism here, everything is God, but here, everything is in God. Everything is in the one. The one, if you is a technical term from Neoplatonism, which might suit better than God. So panentheism. Okay, so now we're almost there. So liberation is an artful construction of top-level priors. And you know what? you might think that the level 1 awakening was kind of very different from 2 and 3. But what is the difference? What is the difference is the priors that were coming at this, the way of looking. This is all that we have. You know, it's not like there's some deeper truth. It's just we're looking at the world in a different way. And here's the funny thing. This is where it gets really weird, and it's going to get paradoxical, which is that some of these priors, right, might end up deconstructing this whole damn model that we just built up. You know, we might like totally deconstruct, saying that this was all bullshit. This is like all an illusion. What are we talking about? We're talking from a relative level, and none of it was just a story to begin with, right? What have we done? We have just, in Wittgenstein's terms, we've used a ladder to go up to somewhere, and now we realize the ladder wasn't real, but I'm up here anyway, okay? I could throw away the ladder, okay? And so I'll leave you with the thing that is my final truth, because I don't believe, which is the elephant in the blind. This is the deepest thing that I know, and I absolutely must insist on, you know, this being the final thing that I say, which is Anekantavada. It comes from Jainism. It's, you know, who knows the elephant in the blind story? Everyone? Only about half. Okay, right. So there's this very important story. This is really important. This is like, you know, a king invites, there are many versions of the story. The Jains claim it, the Buddhists claim it, everyone claims it. But there's this, you know, king that gets either 7 blind people or 7 blindfolded wise men, and you say, you know, what is this thing? He has an elephant there, and someone touches the tail and says it's like a rope. Someone touches the trunk, says it's like a snake. Someone, you know, the legs is like a tree trunk. Oh, the body is like a wall. The ears is like a fan. The tusks is like a sword. Whatever. And the idea behind this is that ultimate truth is complex, many aspects, and maybe cannot be captured with narratives and can't be fully expressed. So we can only have stories about the elephant. And so that doesn't mean that we have to go postmodern and say, well, every story will do. We can have more beautiful stories, but even the criteria of truth or beauty around those stories, how good, we can have better stories and worse stories, but the criterion for betterness is just another story. And so the Jains kind of put as non-violence around it, intellectual non-violence, intellectual ahimsa. But essentially, we can only give a story. The story I have given you is a kind of a modern story of like what awakening is, Dharma. I commend it. I think it's economical and parsimonious, but it's just a story, and it's even eaten its own tail. So that's all I have to say. Because I've used up so much my time, what do you want to do?
I think we could take questions if you have energy.
Sure. Okay, I think I'll send this to you.
Do you have any account of the life review in your death experiences?
No. I mean, you know, I've ideas or whatever, but I don't. There's lots of phenomenology which is going to be out there, but we'll talk about it later. Yeah.
2 questions. One question is, one of the slides you mentioned timelessness.
Yeah.
As part of which slide was that?
Yeah. On Dereification, defabrication.
Yes.
Yeah.
Is on both Dereification, or is it just?
Well, no, you can do both. You can actually do both. This is a very subtle thing. That's a really subtle question. So what's your question?
So the question is around timelessness. Like
Yeah.
which path, or do both sides give timelessness, and
Yeah.
you explain the intuition.
Right.
Is that a spectrum that you're getting to? Like
Okay.
Yeah.
Yeah, so timelessness, you know, in that stack of models, I actually personally think that timelessness is right at the bottom. My teacher has doership, he's Shinzen student, has doership, agency less at the bottom. Personally, I think that timelessness is so, if you really go into timelessness, doer happens within time. So time is right at the bottom of the stack, in my view. So the, you know, so the experience of timelessness is that all arisings, whatever's happening, is arising within your awareness. Like a clock, tick, 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 or things happening, people moving. It's all happening within your awareness. Okay? But the space of the generative model, the knowing awareness has nothing, doesn't have content. Content is within it. It itself doesn't have structure. There is nothing that distinguishes anything from in it that has no internal structure. So time is happening within your experience, but the awareness which your experience is happening in is timeless. And I know that sounds really funny, but so think of sitting on the bank of a river, and the boats flow by, whatever, but you're not moving. And one moment is no different from any other moment. There's no clock. You know, the clock is an arising within awareness. It's not, awareness doesn't have clocks. That's a deconstructive part. Then there's this defabricated part of what does it feel like? And actually the deconstructed, the Dereification part, and that can feel very different. That you're flowing in time. And sometimes that comes across as peace or stillness or some of these other words. So, it's very interesting phenomenologically, you should explore it.
The second quick question, sorry, was I just want to confirm at the absolute ending is what you're basically saying is that just like we're like a microcosm, the larger reality that we can actually, if we go back to that place, people, oh God, whatever, you could actually reconstruct even these stories, these beliefs from that place in any possibility, kind of like the yogis we would levitate, like or is it, are you talking about something different?
I more see it that the stories are part of the fertile arising, and let there be more beautiful stories, and there is nowhere beyond the stories in language. So I'm sort of like, if you want to know, like if you're asking philosophically, I'll tell you that what that means is you have to take a pragmatic theory of truth. So you certainly can't have a correspondence theory of truth if you're a philosopher, which is some proposition is true if and only if there corresponds some affairs in the world that make them true, because we have no access to the thing in itself. You can't take what's called a coherentist theory of truth. You're essentially taking what's called a pragmatic theory of truth, which is some sort of truth is a fiction. It's a good fiction because it allows society to coordinate, but it's pointing to the end point of some inquiry. But there is no final place to verify the truth. So, yeah.
Thank you for the talk. That was really beautiful. And yeah, I had a question. I just wanted to know, do you have any thoughts about when we're venturing into exotic states of consciousness and we're encountering phenomena that are so far removed from the frames of reference that we've internalized to model the world, like, in ordinary conscious states? How do we, when we're trying to bring information back from these exotic states, how do we construct new frames of reference or, new language games, if you will, in order to kind of build the practice of trying to kind of model, the phenomena that are kind of at the edges?
Well, so think that's a very good exercise to do. Shinzen, for example, has invented like and Viviana, you know, like invented this beautiful way of like re-expressing. There's all this Dharma stuff, and then there's the ineffable. So use poetry. Yeah, okay.
You presented this very lovely model of layers of low-level modeling that have the prior taking higher level model.
Yeah.
And I'm wondering, is there an insight we could use from understanding the structure of that can inform how we think about an action we take that can update higher level priors? Maybe that's useful. So this is a two-part question. The first part is like, what can we say about the structure of that? 'Cause you just showed kind of going up one track. I don't know if it's like a tree with a root node or
Yeah. It's more like this.
Do you think there's a root node?
Well, there's the top of that hierarchy, but even that has lots of structure. And the top of the hierarchy might be, for example, I think, you know, the general region is the default mode network. That's where we kind of store a lot of these top level priors. It's not a single top level prior. It's like, you know, things that are at the top of the hierarchy. Yeah.
And then relatedly, there's these two paths: purification first, steep awakening, and then awakening with the purification.
Direct path. Yeah.
In each of those two, how do you think about that from the perspective of like which priors are getting updated? That rapid cascade. First, the other.
Yeah, that's a good question. I do think of liberation as and purification as updating your priors, as your beliefs. And you can do that. You can do these exercises, purification, like, you know, and dissolve a lot of the karmas and samskaras and, like, you know, emotional patterns and stuff way before, and install new ways of looking, beautiful ways of looking before even having, you know, deep awakenings. And that, you know, just endure, you know, many paths that, you know, that happens. And so, yeah, I think that's exactly it. That it is changing one's, you know, priors, and that's liberation is. They're both very important. I mean, if you think about it, to some extent, the ego likes the project of liberation. Because that's what like really gets rid of the kind of painful gritting at life, the patterns that I always get irritated and whatever. But if you start tuning into these higher level priors, forget about you. It's about the universe waking up. You know, like, so, you know, yeah, these are just stories. Next, yeah.
I'm gonna try to think through some of this logic I have about this. So in terms of, you know, your priors and then your posterior and that kind of updating process you go through. And I kind of see some of it, you know, it's like the deconstruction and the dereification, and then it allows you to like rebuild those priors.
Yeah.
Right. But it also doesn't, you know, with this final note that you ended on, like, it's not like you can ever get to your priors being perfect.
Well, what would perfect be?
Yeah, and it's like, this is what like Zen koans are about. Zen koans are about like, here's this inherent contradiction you have in your priors. I'm going to break it in your head and make you deal with it.
Yeah.
Right. And but then another aspect to this that I'm kind of thinking about is like the cosmic joke, like the punchline of it. Like the joy of humor and the joy of aesthetics and beauty in general is that there's this surprise to it that's built in.
Yeah.
That is, it takes you beyond what you thought was possible. It takes you beyond your priors. And that's a joyful experience.
Totally.
And I suspect there's something really important there with these priors of how does that joy work? Why is it joyful in one sense versus it hurts in a different sense?
Okay, good. So this is okay. So there's three or four questions actually there.
Yeah, I know.
Okay.
Thank you for bearing with me.
So you know, this isn't about there is one set of priors to have. You know, in a sense, what's the real thing is to construct many priors and move fluidly between them. And the issue you brought about, that sort of spontaneity, that is absolutely it. In other words, if there is just less priors, you just like spontaneously, like, you know, like, just effortless action spontaneously arising from below. And that's, I think, a lot of it, which is where Wu Wei Wu comes from, you know, like, and I definitely feel like there's this artful reconstruction. It doesn't mean like you have to have, I need to hone into this and this and this. It just be like, you know, I think like there's a kind of a meta prior, which is like, hold your priors lightly, move effortlessly between them. Like, just, you know, see the world afresh and in like new ways all the time. This kind of these meta priors. Now let's talk about joy. So the gripping side, I think I talked about suffering. When things are reified, you're gonna suffer because you take it seriously, like it really matters to you. And guess what? That proof that I had that life is full of negative valence, it really that was what Buddha said, and this is like an updated version of that, right? A mathematical version. But basically, you are gonna be frustrated. You know, you cannot have the world go your way. So if you take it really seriously and gripping on it, you're gonna suffer. So that's all fine. But there is this higher level of joy that I think I'm hearing in your question. Well, which I'm kind of intuitive, maybe you didn't have this in mind, which is the joy of Satchitananda, the Ananda part, which is that when there is just being in awareness, and it's just accepting, it's not just accepting everything, but everything is, any energy coming up from the system is joyous because it's an expression of this infinite possibility. And that can even turn into, there's a spectrum, I think, from like equanimity, peace to joy, to love and joy, which is like amor fati, which is I just want everything to happen exactly the way it happens. And guess what? Everything exactly does happen the way it happens, and it's just all amazing. That was what Nietzsche eventually came to, but that comes from the Stoics. So I think that joy question is very deep. And, you know, I've talked a lot about emptiness, but there's this other side of it, which is equanimity, joy, peace, love, compassion, which is very close to that. Everything is allowed space. So yeah, that was.
I appreciate it.
Yeah.
You mentioned when you're talking about Markov blankets that in that structure, the inside of the blanket have a model of the outside. The outside also a model of the inside.
Yeah.
So what does that mean for the universe? Does that mean that with that analogy that the universe has a conscious cognitive model of every insight?
So you know, what did you just do there? You just said the universe is everything but us, like the external. Yes, but we're also the universe. So I would say the universe has models of itself. Yeah, Shinza.
I've got 5 words to suggest a direction to answer that question. And your response, it's 5 syllables. Yonedalemma.
Right.
It is the central theorem of category theory.
Yeah, I mean, I don't know exactly how that applies, but that's the kind of thing, because it's in a way, the whole has models of itself. You know,
There's
the
an
thing is,
embedding.
Yeah.
The Yoneda embedding that embeds the individual in the universe mathematically.
And here's the funny thing about this. My model of the universe must include the universe's model, the external universe's model of me, and then back and back starts getting pretty, that's like, talk about one. Yeah.
In the drama.
Yeah, Indra's net, yeah. Also, Indra's net, yes. That's it. That's a really beautiful way of looking at these things. Just jewels in a net, all reflecting off each other, all reflecting the whole. It's like that's
Also, Huayan and Tiantai, the pre-Chan schools in China,
yeah. They had something like Indra's net.
they apparently discovered it on their own.
Okay, right, yeah.
Practice.
Indra's net is like a really deep. I mean, that's a, like, if you want a good story, Indra's net is a good story. Yeah. Sorry, back there, yeah.
So we discussed this like generative model.
Can you speak up? Sorry,
Yeah, so we're discussing this generative model with as an output. You care to speculate? I don't know much of the physicalist you might be, but would you care to speculate as to where that might possibly be rendered?
All right. So you mean where the nominal experience is rendered, or where the generative model is being like, so the brain is obviously this. I don't think what you meant is that the brain is simply the generative model. I think you're asking me some metaphysical thing, which is where is experience?
Sort of. I guess I'm from a very physicalist mindset, and I have to consider that maybe this might like correspond to some particular physical state within the brain, one technical region.
So okay, if you're a physicalist and you think there are neural correlates for consciousness, there will be neural correlates for the output of the generative model. Some of that interesting data on that is that the latest things, the one that was all the kerfuffle around and calling IIT pseudoscience, is that basically the neural correlates of consciousness are a lot at the back of the brain, but also at the front. Yeah. So the posterior hot zone is like, if that's the answer you're looking for. But I think what you're really looking for is like, oh, where is consciousness? It's all an illusion. Yeah, maybe it's an illusion, but who's having the, what's having the illusion? So there's something there. And it's a deep question, which is, you notice that I very carefully, I could give another 2 hours on consciousness, but I very carefully try to pare out all the stuff on consciousness, because it's a tricky business. And that's one of the reasons, you're really asking about the hard problem here. And if you want to know, like, what are my metaphysical views, I would say, broadly, I'm a monist. But monist could be physicalist, idealist, or neutral monism. When I'm in my more humbler moments, I say neutral monism because who knows? But something that's maybe continuous with consciousness, mind-like. And physicalism is a lot less physicalist than most people think. You ask a common person, like the person on the street, like about physicalism, they'll tell you about billiard balls and like, oh, so the physics is not like that. So physics is like, it's really like, what does it really mean? And so the difference between physicalism and other monism is becoming less and less. So I'm just like, yeah, consciousness is an interesting one, but it's the one, I mean, the real insight of Descartes was not all this thing, this other stuff. It's just at least that there is experience. You could have just stopped there. There is experience. That's the one thing. And who knows whether there's physical stuff. So I take that seriously. Yeah.
So if
You had a fourth question.
If you at that part where you took the autoencoder and the encoder decoder, fold it in half,
Yeah.
And you got the error at the bottom, that was feeding back up to the
Yeah,
top.
yeah.
How does that work actually, the here on look? Because then I'm not sure, like, you're saying that the model generated fed out to where the perception is?
Yes,
It's there.
yes, exactly. This is the weird thing. This is how, do you know how radical this is? We think right at the edge of the sensory cortex is where my sensory data is coming in, but then you actually look at brains and it's filling in left, right, and center into the actual final layer, where the data comes in. It's actually literally, I mean, this guy, Jay knows more about this stuff because he's a vision scientist, right? Like, but it's doing that all the time. And layers above it are like saying this is the foreground, this is the background because I can eat it, and this is really important because it's dangerous, and this is where the edges are, and it's doing all that cartoon rendering right there down. I mean, right at the edge. Isn't that right? Yeah. Yeah.
Yeah, I'm trying to connect the dots. Actually, I have this hunch about weighting and its relationship to redundance and the
Precision weighting?
yeah, precision weighting and the propagation of nothingness. The balance shifts from weighting somethingness and information. You start to the absence of information maybe more equally, and the idea that could propagate because the brain has redundance, so you get this effect of, and I wonder, could you speak to, like, when you're talking about weighting, does that include this concept of redundance, and does the concept of redundance does it have any relevance to this concept of weighting? I'm just curious.
What sort of, is it redundancy in pathways, or do you mean?
Yeah, I'm recalling it from a conversation a long time ago. Basically, the idea that that information is passed, as I understand it, correct me, through the brain. There are multiple ways to pass that information along, because you need to ensure that if some part of the brain doesn't function properly, it does. So
Right. This is all, no, okay, I think I know where, so you're already coming from this, like this precision weighting and the attentional system.
yeah.
And this is very good. Okay, good. So this is about the details of attention. So there are these two systems in the brain that seems to, this is more on the like detail level, but like there's the dorsal attentional network and the ventral attentional network. And one does top-down attention, and one does bottom-up attention. And then there is this peripheral awareness, something like, and we don't exactly, but you're right, because when I decide to pay attention to this, and it sort of dominates my conscious gestalt, that's one kind of attention which we use in meditation. And then there is this, I'm standing there and in a forest, and there's some rustling in the leaves behind. I'm like paying attention to this animal in front of me, and there's this rustling behind me, and somewhere deep down, this is the more ventral attention network, like it just filters up by itself and then calls out to consciousness saying, "Hey, me." There could be a snake there or whatever. This whole dance of attention, I see where you're coming from, because it's a really important thing, because to some extent, meditation is the art of getting more mental action, more, holding it and making it less, more mindful, the whole thing more mindful. But in a way, there is this system which is this peripheral awareness that is even below the level of consciousness, below what is broadcast in the brain, which I think is very important, and a separate training target in a way.
So I think I hear you saying that the propagation is related to the peripheral awareness. That is the kind of, is that what you're saying?
Well, the propagation of like things coming up from the bottom to call the attention.
In other words, if we're passing along information, the data,
Yeah,
then, what if the data we're passing along, what if the value we place on certain types of data, it diminishes, the reification reduces, and the emphasis we play on other type, the non-data, the absence of data, could that
oh,
value?
you're
increase
thinking about like, oh,
the weighting in that.
yeah,
sense?
that's a,
Yeah.
oh, now I think, oh, this is very deep. This is like, can I make more of can I make more of my conscious experience the ground of being, the awareness itself? Can I carry that awareness? Can it be present?
That's a
that
weighting
stillness?
process.
Yeah. Oh, I love it. You know, I
Yeah.
thought about this, and it's a very interesting thing. And there's always a worry to me, which is, me? I don't know how to answer the question, because to some extent, I feel like that pure nothingness is not a thing. But in another sense, experientially, we can make it more a part of our experience.
Yes.
It's a beautiful question.
Yeah.
I don't know.
Yeah.
But it's very relevant experientially. Yeah. Great. Shall we?
Thank you.
Should we stop the recording? Wow. That was the